For assignment number 7, we need to draw this two bodies intersection. So we need to find these intersection lines in the top view, in the left view, and then on the right view. So these intersection lines. So there are two bodies are given. First body is a cone, this kind of shape, and a prism. So we don't need to draw this table in this isometric view. Just only the things, all the shapes are given with the parameters in the chart and with the different values. So I'm going to show the number 1, and the shapes, some shapes are big and cannot fit in this given page. Okay, so in that case, we need to scale it. So for example, I'm going to show this first one, and the size is big, so this is why I want to scale it by 1/2. Okay, so 2 times smaller. I'm taking from these values and then reducing 2 times, and I have to write here 1/2. So the values are this one, already reduced 2 times. For example, here with an R is equal to 60, but in my case it should be 30. Okay, and how to organize it? So vertically, this vertical size of this A3 is 297. So from this 297, I'm minusing 5 from upper side, 5 from lower side, and so I'm minusing 10 here. Minus 55. 55 means this title block height, and minus 70. 70 is the height of this cone, and minus 72. 72 is this prism length. Okay, so this one. So the value, the summation value should be divided by 3. So here the empty place another second one and third one. So if you divide that, is a 30. So I have to leave 30 after this frame, and then So this point is located in this plane. Okay, so one plane. If we cut this cone with this plane, one plane, we'll get circle with a diameter of from here to here. Okay, so radius is from here to here. Let's draw that circle by putting the needle here, and then let's make the size of the radius is here, so that 2 points are located in this circle. Okay, so we draw just only 1/2, so arc, and then we can project, okay, so this point into this circle part, so that is this point is here, and the cross section of this line, and then this circle. So this is, if you say this is inlet and that is outlet. And second, 2 and 2, plane 2 and 2, so a little bit bigger. So we can project it like this way. Here one point, and another point is here. And here one point, another point is here. Okay, 1, 2 point in inlet, and 1 and 2, there are 2 points in outlet. So same manner we are doing the third one. 3 and 3. Can project it. Here 1 and 2, and 1 and 2. Okay, the plane 4 and 4. So let's project it. Okay, and the last one is almost same as on the edge, just a little bit smaller. So it's in this edge, this side, and that one is on that edge. So from this point is the prism is visible, okay, and inside of this one, so the cone base is invisible, so that's why we're making a dash. This region and that region also can be a dash. Okay, and if you project it this point to here, what will happen? The last one is almost here, almost near to the prism. That's visible side, and then that's also visible. Okay, and that side visible, and that's visible. Okay, then let's connect these points just with using a like this curve. And then the other side. Here we have some okay, now it's correct. So I'm searching for it. So now that is correct. That is visible edge, visible edge. So here we have a tip point of this. So now these points can be projected to the other views also. So how to do that? We can do like this. So just divide this region, so 5 centimeter, right? So 50 millimeter by 2. Just divide by 2, and then that is 2.5 centimeter. And then draw like this line. And divide that side also, so that is 36. You can divide by 2, that is 18. Draw very thin line, very thin. So you can divide this 5 centimeter. There's a 2 portions, 0.5, 25 actually. Okay, so now we can project to the left and right hand side. So by the way, without drawing this one, if you measure this thing, this points from this horizontal line, that distances can be inserted in here from this central line, from this vertical central line, and then every point can be find at the position, and every point position, vertical position, should be projected from here, and that vertical position. A horizontal position can be measured from this distance, from this line up to this point. And by using this one, how to make, just project it. For example, first point, where we get that first point circle is this one, so this point and that point can be projected into this line, this axis, and then can be projected to the upper side. So we are doing like this projection. So after finding these points, we can connect them back side of the cone base will be a dash, so invisible from here to here and from here to here, and all those points can be projected to the another side views by this way. So here, if you see this task description, there's different projection types are shown, like this one. So this is valid when we have the distance, same distance from here to here and then from here to here. That means from this place to this base of the cone, and from here to the base of the cone is the same, so then that's valid. But in our cases, the distance of from here to the cone and from here to the cone is different, so that is not square shape, this is rectangle shape, so then we can do like this way. So all these points, first we have to do with the center, so center go here, and center goes here and met here, and then the cone base should go until it meets here, so crossing here. So then we can do like this straight line, and here also should meet, and then that should be linear. So the another side also should be a linear like this one. So then all these points can be projected until this line, and then crossing it, and from this point should go to upper side, and each line have own planes, right? One in one generate this one, so same level. Okay, so this point should go with that way and then go to its own plane, okay, somewhere. And then second one is this one and then that one, this one and then that one, so this should go with that way and then on the level of second. Okay, so we have to do that kind of projections. Finally, we got projections. So this first point is going to the first plane and got here and got here. Second point, we have 2 points in here in second section, and those are going with that way, here and here, and here second also, here and here in the same plane, second and second. So on, 3 and 3, 3 and 3, 4 and 4, 4 and 4, 5 and 5, 5 and 5, 5 and 5. But the only thing is, this region we are looking from this side, and that's visible region. So that's why all behind this is are with dash, and that region is visible, and this cone side and then the back side of this curve is invisible, so that's why it's given a hidden feature, and those are visible, but this side is opposite side, so these are visible region, but these are invisible all, so that's a invisible there. So here visible region is only this prism, and then the side of the cone all are visible, so that's why we can draw this as a continuous thick line like this. Then at the end we have to refine it. Like this. And at the end, do not forget, sign your name and Write your signature. Okay.